Yesterday when we were talking about two equations with two unknowns, that was linear equations, right? Or parabolas, right? But we were finding out where they intersected, and we were only in 2 dimensions. The minute you have 3 equations with 3 unknowns, now you're talking about systems of equations that involve planes. Okay, we have 3 dimensions, and so now we're dealing with planes. So when we intersect a system of equations with 3 variables, 3 unknowns, right? 3 equations, 3 variables, 3 unknowns, we're going to end up with a solution with 1 point most of the time. Okay, we'll find an ordered triple. Yesterday our answers were ordered pairs. Now that we have an x, y, and a z, we'll have ordered triples. Sometimes, though, we can have a solution that's a line. So we'll deal with that case as well. Okay. Other times the solution can be that it's just one plane in disguise. Okay, same plane written 3 times over. We could have 3 parallel planes with no solution. And finally, we can have 3 planes that intersect but don't intersect in the same place. So they're not going to have a consistent solution as well. Okay. All right, so here we go. Sure you remember these from last year, at least doing them, probably not enjoying them. We have 3 equations. One of them is x minus 3y plus 2z equals 1. A second is x minus 5y plus z is a negative 5. And a third is 3x plus y minus 2z equals 1. Now, there are various strategies for solving this, and one that I do like is called row echelon or using Gaussian elimination. But I'm not going to show that to you because you've probably not seen that before. Most likely your teacher has said, hey, let's focus on one variable and eliminate it first. So if you choose to do Gaussian elimination or the putting it in row echelon form based on what is in the book and what they have in the videos from the book, you're sure welcome to do that if you want to try a different alternative method. But in thinking about time, we're going to try to use the same system, same process that you used last time. So when we look at these, we have to be strategic. And we say, which is going to be the easiest variable to eliminate? Z, okay? Many of you are saying Z because if I wanted to eliminate x, I would have to multiply the top by -2 and then also by -3, right? That's too much, okay? We look at the y's and I'd have to multiply the last equation by a +3 and a +5 to make the y's disappear. But at least with the z's, we can add the top and the bottom equation up, and that quickly gets rid of the z, okay? So we're going to do that first. So we start by adding equation 1 plus equation 3. So we're going to get x plus 3x and a -3y plus a y. The z's go away and we get 0. Okay, that wasn't so bad. But now, that was adding these 2 equations together. Now we've got to use 2 different equations to eliminate z again. Okay, so which one do you want to use the middle equation with, top or bottom? Bottom? Okay, that means that we're going to multiply this one times 2. So we will have a 4x minus 10y plus 2z equals -10. And we're going to add it to the bottom equation so that the z's will go away. So we add these 2 up, 4x and 3x, -10y and a positive y, and a -11. Okay. So now I have two equations with two unknowns, right? And so I want to use these two equations to eliminate an x or a y. Okay. So I have 4x. Do you want to eliminate the x's or the y's? X's? Okay. So we're going to take this one times what to make sure the x's go away? 7. Okay. So we'll have a 28x and a negative 14y equals 0. And then we're going to take this one times what? Not a positive 4, a negative 4. Okay, so we're going to get a negative 28x plus 36y equals a positive 44. These are gone. 36 minus 14 is, so 22y equals 44. And what's y? Y is 2. So we have a part of our answer, 1/3 of our ordered triple, and y is listed third because x is first and z is last. Okay. Now that we have the y and we know what it is, we can plug it back into either this equation or into this equation to find out what x is. You could, but then we would have still an x and a z. So if we plug it into this one or this one, then we'll know what x is. And then eventually, once we know x, we can plug it into any of the top threes, along with y to find z. Okay, so y is 2. I'm going to plug it into this one. It's easier, right? So 4x minus 2 times 2 equals 0. Negative 2 times 2 is a negative 4. So when I bring it to the other side, I'll have a positive 4. If 4x equals 4, what's x? 1. We've got the second number of our ordered triple, but we list it first, so we go alphabetically. Okay. Now we plug both x and y into any of the three equations to find out what z is. Okay. Maybe the top. We plug x in for 1 in for x, minus 3 times 2 in for y, plus 2z equals 1. I get a negative 6. So I'm plugging 1 in for x in the top equation. 1's going in here. 2 is going in for the y. And I'm going to find out what z is. Okay, it doesn't matter which equation we put it into. We should get the same answer. Okay, so I've got a negative 6 plus 1 is a negative 5. If I add 5 to both sides, I'll get a 2z is 6. So what's z? Yep. And I would recommend that you make a little dash or something in your z's so that you don't confuse them with 2's. All right. So the strategy on these is to use two equations to eliminate two pairs of equations to eliminate one variable. And then once you have those system of two equations like we had yesterday, eliminate another variable. Okay. And then plug that number back into one of those two equations with two variables. Find out what the second variable is, and then plug those two that you found into one of the top three equations. Okay? What questions do you have about this slide? All right, next one. X plus y plus z equals 2. 2x plus 3y plus 4z equals 5. And x minus z equals 1. We were given a gift. We have an equation with one variable missing, right? Okay, so y's already been eliminated from our third equation. So let's do what we can to eliminate y from these two. What do we need to multiply the top equation by to make the y's disappear? Negative 3. So we'll have a negative 3x minus 3y minus 3z, and be careful not to forget to multiply that 2 by a negative 3 as well. Both sides of the equation, every term by the same number. So if I took a negative 3 times this, and I'm adding it to this equation, the second equation, I get a negative x, y's are gone by design, plus z equals negative 1. But look what happened. Now when I add these up, what do I get? So my new equation was this one. Yep, when I added the red plus the second, the new first one plus the second, I got a negative x plus z equals a negative 1. So I eliminated y from those two equations. Now when I add it to my third equation, I got 0 equals 0. What did that mean when we had 0 equals 0 yesterday? If it was 0 equals something that wasn't true, so if we had a number, it was one solution. But if we had a 0 equals 17, then that was false. We said no solution, right? This one's an infinite number of solutions, okay? But we don't get to stop there. We want to be able to generate some points along that line. So when we see that we have a true statement and we know that those planes are intersecting all three in a line, we want to find out what could values be for those points. So what we typically do, and it doesn't have to be z that you say is going to be equal to a constant, but we typically say z equals some letter like a. Okay, this is going to be a real number. And we want to see how y and x compare to z. Okay, so if we let z be equal to a, okay, then we're going to have an ordered triple something something a, where a is a real number. Now we say, okay, if z is equal to a, then let's plug it in. Negative x plus a equals negative 1, right? Or we could have plugged it in here, would have been better. Okay? X minus a equals 1 is better. Because what's x going to be when we solve it? We'll get the x by itself. X is a plus 1. So whatever number we use for a, the x coordinate will be 1 bigger. Okay? So now that we know what x is and what z is, let's plug it into any of the equations. I'm going to say the top one's probably going to be the easiest. So we're plugging a plus 1 in for x, plus we're plugging in, we don't know what y is, but we're plugging in a for z, and we're setting that equal to 2. Okay? So when we solve this, we have y plus 1 plus 2 of these a's equals 2. So if I want to solve for y, I'm going to bring that 1 and that 2 to the other side, 2a to the other side. So I'll have a negative 2a, and if I take away 1 from both sides, I get 1. So whatever number I choose to put in for a, if z is a, then x is 1 bigger, and y is going to be negative 2 times that number plus 1. So there's lots of points that will satisfy this equation, or this system of equations. I could let a be 0. Then what is x going to be? 1. And what will y be? 1. If I let x be, or a be 1, then the x value will be 2, and the y value will be -1. These 2 points will satisfy all 3 equations. I could have decided to let a be -3. Then the x-coordinate will be -2, and the y-coordinate will be 7. Those 3 points plus an infinite number of others are going to satisfy that system because they can connect in, those planes intersect in a straight line. Make sense? Okay. All right. I think, how are we doing on time? Doing okay? We use a lot of time to talk about that graphing thing. Number 62 in your book, or on page 498. I've made the font really small so that I can see it, but you probably can't see it from where you're at. So if you can pop your book open to page 498, number 62. We'll talk about how to set up a system of equation with 3 variables. Something we can always use practice on these word problems. Okay? We have an advertising budget. We have a health company, health insurance company that likes to advertise on TV, radio, and newspaper. And they have a budget, marketing-wise, of $42,000 per month. Television ads cost $1,000. Radio ads cost $200. And newspaper ads cost $500. The department wants to run 60 ads per month and have as many TV ads as radio and newspaper combined. So how much of each one should they purchase? Do you want to use T, R, and N, or would you like to use X, Y, and Z? Doesn't matter, does it? Okay, as long as we know which is which, right? So let's use X, Y, and Z. X is our number of TV ads. Y is our number of radio spots. And Z is our number of newspaper ads. Okay. So how many ads are they wanting to have in a month? 60. Number of newspaper plus number of radio plus number of TV is 60. Okay. How much do each cost? TV costs 1,000, right? How about newspaper or radio? 200. And how about TV or newspaper? And how much are they spending a month? Okay, so our second equation. And our third equation says that we want to have as many TV ads as radio and newspaper combined. So we want TV to be equal to radio plus newspaper, right? So if we bring everybody to one side, X minus Y minus Z will be equal to 0. Okay, so we've set them up. Now, do you like working with big numbers? No, me neither. So what should we divide everybody by to make these numbers more manageable? To 100. Okay, so let's take everybody and divide them by 100. You could almost do it by 200, but we'll end up with a decimal, right? So let's divide everybody by 100. We'll have 10x plus 2y plus 5z equals 420. Right? Check my math on that. Okay. Now we've got a system of 3 equations that we can work with. Make sense? All right, we're getting close on time. You want to see it worked out, or are you okay now that you've got them set up? Okay, setting them up is the hard part. Finding all of what we need in all, 3 equations out of those 3 unknowns. So the first step was just to simply say, let's take our number of adds. Oh, to solve it? Okay, so I would say I've got an x, I've got y's and z's that are going to go away, right? So if we add this one plus this one, x and x is 2x, y's are gone, z's are gone, and we get 60. So we immediately know that we're going to need 30 TV ads. Okay? And then we work our way from there. Okay? So now that we know it's 30 TV ads, you can plug 30 into both of these, and you'll have just 2 equations with y and z. Or you could say, let's eliminate y next, or let's eliminate z next. So backward substitution, if you said this, then 30 minus y minus z equals 0. So negative y minus z is a negative 30. And then same thing here, right? 30 plus y plus z equals 60. So taking away 30 from both sides, we'll have a y plus z. Oh, we get that same thing, equals 30 again. That's not going to help us. So let's plug it into the next one. Let's put 30 into this equation. So 30 times 10 plus 2y plus 5z equals 420. So we bring that over, and 2y plus 5z is a 120, and now use these 2 equations to get rid of a y or z. Okay? All right, let me get you an assignment real quick. So we're in the process